All right, I'd like to, for Algebra 2 on Wednesday, March 23rd, I'd like to continue talking through our normal distribution and z-score notes. We started these notes on Monday, the 21st in class, and they need to get finished today, so I'm leaving the notes with you with the guest teacher. You need to have your pink normal distribution and z-score notes out so you can continue this. Everything I'm going to show you from this point is going to help you on the assignment that you have today. Your assignment today is going to look like this. There are 1, 2, 3, 4, 5, 6, 7 problems. I'll put lesson notes in here enough for you to be able to go through and work those 7 problems. In doing so and getting ready for this, though, I do need to have you finish up these pink notes and the discussion on them. Normal distribution and z-scores assignment. If you were absent in class on Monday, this packet of extra papers will be in the guest teacher's hands. Raise your hand if you haven't already gotten one so you can start working with me from where we left off. The first thing is a normal distribution. We had written down the definition that it's a bell-shaped curve that shows how data is distributed from the mean. We watched a quick video on the normal curve and examples of it in real life with standardized test scores like the SAT, which you guys are sitting down to take a practice one today, and then the empirical or the 68, 95, 99.7 rule. And we made some markings on this drawing class on Monday in order to better understand how that one standard deviation from the mean is going to be adding one standard deviation and subtracting one captures 68% of the data. 2 standard deviations from the mean is going to get us 95% of all the data that's in the distribution, and 3 standard deviations of the mean is going to take us to 99.7% of the data. And we actually made this a little bit more accurate. It was off just a hair from what I know as being a statistics teacher, that in the tails there was 0.15% outside of that 3 standard deviations rule, so we wrote that there. We ended class and our discussion on this with just drawing a normal distribution here, and what we're going to do in this example, it's the grades on a statistics midterm. They're normally distributed with a mean of 81 and a standard deviation of 5. So what we're going to do is draw and label the normal curve, and actually this is one instance where I won't start with a number line first. I'm actually going to start with going down the middle and drawing in the line to show that the mean is 81. In a normal curve, and this came up in our discussion Monday, the mean and the median are going to be on the line of reflection. And then what we want to do from that, and I'm actually going to make that a solid line right now, what we're going to do from this line of reflection and this mean is we're going to use the idea that within 1 standard deviation of the mean is 68% of the data. I'm going to come out and kind of, actually, I'm going to have you do this with, hopefully with your pencil. Take a second, we're going to try to mark off, and if it doesn't, I'm going to try to mark off equal pieces or equal chunks from the mean, 1, 2, 3 equal pieces over, and then to the left of it underneath values below 81, and then I'm going to do the same thing, and I'm kind of trying to make this look as equal as possible. I still show these little tails, but do that on your paper right now, and if you have to make some adjustments and erase with pencil and whatnot, but I want to try to show from the mean 1, 2, and 3 standard deviations, and I'm going to give you a few seconds to do that. And then we'll go down to the bottom and we'll talk about what numbers go under there. So the empirical rule is useful to us because it can tell us what proportion or what percent of people score within a particular range. Knowing that this standard deviation is 5, all I'm going to do on my number line is when I move above the mean, I'm going to add 1 standard deviation above the mean would be adding 5 to 81. 1 standard deviation of the mean above the mean is somebody that has a score of 86. So I'm adding 5 to mark 1 standard deviation. I'll add 5 again. 86 plus 5 is 91. And that'll go out here at the 2 standard deviations mark. And then I'll add 5 again and put us at a 96 for the 3 standard deviations mark. This makes sense to me. I'm thinking that this is probably just percentage grades. 81 being a B minus and 96 being, you know, real close to 100. So anybody scoring those high A's is going to be represented in this tail. And then I use the same idea going to the left, except now I'm going to subtract. From 81 minus 5 is going to take me to 76. That's 1 standard deviation below the mean. 81 minus 5, or I'm sorry, 76 minus 5 again is going to take me to 71 here. And 71 minus another 5 is going to take me to 66 here. So we've got 81 as the mean. The range between 76 and 86 captures 1 standard deviation from the mean. 71 to 91 captures 2 standard deviations from the mean. And 66 to 96 captures all the data within 3 standard deviations of the mean. So we're going to go and answer some questions. What percent of the data falls between 76 and 86? Well, I actually just had pointed that out. That's within 1 standard deviation of the mean. And up here, that's our 68%, 34 plus 34. Goes right along with our 68%, 68, 95, 99.7 rule. I'm going to put that in there, and then I'm going to grab myself another color to go on and sort of, you don't have to do any shading, but at the same time I think my shading is going to help you sort of see what values they want us to include. Part C, what percent of the data falls between 71 and 91? Well, that's going to take us within that 2 standard deviations of the mean. And within 2 standard deviations of the mean is 95% of the data. Then there's the question about, so these first 2, within 1 standard deviation, within 2. Now what I'm seeing here for part D is this is getting us to look at not those 68, 95, 99, 7 parts, but putting and figuring out what proportion of data is between 81 and 91. So actually what I'm going to use in order to answer that question, I'm going to go up here. In this piece between the mean and 1 standard deviation, from our picture up top, that's 34% of the data. Now in this piece between 86 and 91, that's broken down and telling us that that's 13.5% of the data. So hopefully you have a calculator next to you. This is the kind of thing you're going to do on your own. 34 plus 13.5 is putting me at 47.5% of the data. I sure hope you're engaging your brain right now, because this is the only lesson you're going to have before you're in a situation doing this by yourself. And actually, as I'm looking at your work that you're going to do today, I can see you're going to draw and label this normal curve. And then you're going to have to answer questions about what percent of students, and in this case, they're actually saying, what's the range of values for 68%? What's the range of values for 95%? So using the pieces on your pink notes is going to help you. What percent of the data is less than 86? This is a good question because it actually gets us thinking about the entire curve. So less than 86, it's talking about everything, and this being my last one, it's talking about everything left of the mean, everything from the mean to the left, plus this little chunk here we already know is 34%. Well, the mean of the data actually splits. There's from the mean, since it's the median, 50% of the data is this way, and 50% of the data is this way. So in the case of trying to get less than 86, well, less than 86 is going to be this little 34% piece, 34% from 86 down to 81, and then I'm going to have to add to that 50%. So 50% plus 34% is going to put me at a total of 84% of the data is less than 86. Excuse me. And again, from the center point of our distribution, when it's cut in half, that's where I got my 50% here. The mean, which is the same as the median in a normal distribution, cuts the distribution in half, so 50% below. And in this case, I needed to add this little chunk that I know is 34%. I'm going to move on to the back side and introduce another idea related to the normal curves and z-scores, or the normal curve, and they're called z-scores. A z-score is a value that measures how far a piece of data is from the mean, a value that measures how far a piece of data is from the mean in terms of standard deviations. The z-score is a value that measures how far a piece of data is from the mean in terms of standard deviations. So it breaks it down into units, and the unit being, it breaks it down into a unit of a count, how many standard deviations away. So to get a z-score, a value that measures how far a piece of data is from the mean in terms of standard deviations, trying to take some pauses. Talking by myself in an empty room, I want to make sure I'm giving you time. Now, a z-score has a formula. So this is just the formula for the z-score. X is going to be your piece of data. It's a test score, maybe. Now, mu, this symbol right here is read mu. We heard the woman on the video yesterday talk about it. Mu represents the mean. Now, in some cases, you may be getting that out of your calculator and looking for the x bar. This symbol mu is related to a population mean. Add up all the data, divide by how many, get the mean. We've called it the x bar. Please recognize that mu is also representing mean. Now, this denominator, so we take piece of data minus the mean. Once we have that numerator value, we divide by sigma, which we learned yesterday is the symbol for standard deviation. Oh, actually, no, that was last week when we did our notes on the MAD and the standard deviation and variance. So sigma represents our standard deviation value. Z, of course, this was called a z-score. The z-score equals piece of data minus the mean. Figure that number out, then divide by the standard deviation. And I'm going to go through some examples here, and I'll show you what that looks like. I've got my calculator handy. You'll be doing the same types of things on your classwork when I'm done here. The grades on a statistic midterm are normally distributed with a mean of 81. I'm going to circle that, and I'm going to put that mu symbol under there. I'm going to use it. And a standard deviation of 5, I'm going to circle that, and I'm going to put my sigma right there because I'm going to have to use it. It wants me to find the z-scores for each of the following numbers. So like I was saying, so each of these, I'm just going to put a little calculation underneath. I'm going to break this down so I have some room for each. So the z-score with a test score of 65, we're going to set up a fraction bar. The test score minus the mean divided by that standard deviation. So I'm going to go into my calculator, and right now I just want to stress the importance of you finding out what that numerator is. I went into my calculator and didn't put parentheses around it. I just did 65 minus 81, and then I'm going to divide that by 5. And I'm going to get a z-score of negative 3.2. Now, the fact that this is negative tells me that this student scored 3.2 standard deviations below the mean. They scored below the 81. We can tell by looking at it. And in terms of standard deviations, that was 3.2 below the mean. If you want to go through and do the entire calculation in your calculator, you can see on mine I actually did 65 minus 81. Pressed enter and then did divide. If you were to put it all in without wrapping parentheses around your numerator, you're going to get a completely different answer than I did because your calculator will do 81 divided by 5 first. So if you want it to follow the order of operations of simplifying the numerator, then dividing by 5, you just have to tell it by wrapping parentheses around the top. I'm going to use this method for my other calculations as I move forward here. Z is equal to a test score of 83. 83 minus 81. Yeah, maybe I'm not going to go right to my calculator because I can do that math in my head. 83 minus 81 is 2. 2 divided by 5 is going to put me at 0.4. Student with a score of 83 on the test is just slightly above the mean, 4/10 of a standard deviation above the mean. A test score of 100. This is well above the mean, probably the best score you can get. 100 minus 81 up top, divided by 5. Piece of data minus the mean divided by the standard deviation. You can go straight to an answer. I know that would be 19 divided by 5. I'm going to go put it in my calculator. 100 minus 81. I've got that in parentheses. Divide by 5. I'm getting a positive 3.8. This student scored very, very well. 3.8 standard deviations above the mean. Their score would sit over here in this tail if they got 100. So not this being a very thin piece of the normal curve. Not very many people are scoring in that range. Piece of data minus the mean divided by standard deviation, and it gets you there. Now, in example 2, the following set of data represents heights in inches of the Greenwood High basketball team members. So this is only going to take me a brief moment. I need to know, and they give me all the heights and the direction to find the z-scores. If I'm going to find the z-scores on anything, I have to have the information about the mean and standard deviation, and luckily our calculators give us the ability to do that. So if you're sitting there kind of hemming and hawing and feeling a little bored, join me by putting all this data into your list. If you're still writing examples, no problem. Oh, I feel like I might have missed something here. Let me double check. I have 16 pieces of data. There's 4, there's 4, there's 4, there's 4. Cool, I got it. So I've got my data in my calculator. I'm going to go pull stat calc, one variable stats on the data I have sitting in list 1. I'm finding out that the mean height is 71.625 and the standard deviation. And I'm actually going to go down here and take this value of sigma. Standard deviation as S we have used out of our calculator in our work last week with 3.2. I'm actually going to go ahead and have you guys recognize here that that sigma of X is also on your calculator. 3.099, I'm going to call my standard deviation 3.1. My mean, let me round to the tenths place as well, 71.6. So my mean, my X bar, I'm going to use my mu symbol, is 71.6. And my sigma that I'm getting right out of there is 3.09, or I'm going to round that to 3.1. Then now that I have that, I'm going to go through doing the z equals. This is a height of 66 minus the mean of 71.6 divided by 3.1. I'm going to come back in a second and do these calculations. I'm going to set them all up. Z is equal to, I put my fraction bar, 73 minus 71.6 divided by 3.1. Z is going to be equal to, fraction bar, 80 minus 71.6 divided by 3.1. Now when I go into my calculator, as long as I go and wrap parentheses around these, I shouldn't have any problem finding out what that z-score, how far each piece of data is from the mean in terms of standard deviations. And there is no shortcut around this. I know last week we messed around a little bit with some shortcuts to our calculator to get at, what was it, the MAD. We were playing around with the MAD. I've got a z-score of negative 1.8, and I'll tell you, with my work with statistics, we typically round z-scores out to the hundredth place. But anyhow, on last week when we were messing around with the mean absolute deviation, the MAD, I showed you some calculator shortcuts. And I don't have any for this skill at all. I'm getting 0.45. So this piece of data is 45 hundredths of a standard deviation above the mean, not much. You can see the difference of scores is not much. And then last but not least, 80 minus 71.6. Wrap that up in parentheses and divide by 3.1. And I'm getting 2.709. I'm going to round that to 2.71. This is just like the work that you're going to need to do. I'm going to go into example 3 here, where I have all the data again, find the z-scores. To save myself a minute, I'm going to look to my notes and figure out what that mean is. What is the mean and the standard deviation I use? I actually have it in my notes. So the mean and standard deviation that I will use for that, the mean is 78, and the standard deviation is 16. Mu is 78, sigma is 16. I need that for each of these calculations. Giving myself some space to do all three. Z is equal to 44, class scores on a test, 44 minus the mean, divided by 16 is the standard deviation. I'm going to set these all up again and then come back and do the work. 68 minus 78 divided by the standard deviation. Z is equal to 96 minus 78 divided by the standard deviation. And then as long as I put parentheses around, I can put those into my calculator all at once. Let me give you what those values are. For the first one, I'm getting a negative 2.13. For the second one, 68 minus 78, negative 10 up top, negative 0.63. I am doing some rounding because, like I said, we're going to go out to the hundredths place. 96 minus 78 divided by 16 is going to give us a 1.13 here. Piece of data minus the mean divided by standard deviation in every case. Now, last but not least, in example 4, we actually are in a situation where the z-scores of 4 students on a particular test are given. So they're giving us the z-scores, not their scores, what their z-scores are. They tell us that the mean is 85, the mu was 85, and the standard deviation was 4. Find each student's test grade. So the way I see this is we're actually just working backwards. We need to look for this piece where we're going to be able to fill in what z, standard deviation, and sigma is. So we're going to have to use our algebra skills and just work backwards to solve for what the test score was. When I look at Zach then, so I'm going to do a z-score on Zach. I hope I have enough room. You guys know I write pretty big. Let me move this over. Sigma equals 4. Try to see if I can do them in this little... Alright, so here's Zach. Zach has got a z-score of negative 0.75. That's going to be equal to what he scored minus 85 divided by 4. Now, in order to solve this algebra problem, I need to undo divide by 4. So the first thing I'm doing in my calculator is going negative 0.75. I'm going to multiply both sides of this problem by 4. 4 is going to cancel out on this side. Negative 0.75 times 4 is going to be equal to negative 3. Negative 3 equals x minus 85. Now, to finish solving, I'm going to add 85 to both sides of this equation. Negative 3 plus 85 puts Zach at a score of 82. 82. It makes sense to me that his score was 82. He had a negative z-score. His z-score was showing me that he scored below the mean. The mean was at 85. So it seems reasonable to me that Zach scored an 82. Now the method of setting up and undoing is the same for each student. So now I'm going to go to Taylor. Taylor had a z-score of 3. What did Taylor score on the test? If I take away 85 from it and divide by 4, I'll find out. If I multiply both sides of this equation by 4, 3 times 4 is 12. X minus 85 will be the only thing that remains on the right-hand side. Once I multiply both sides by 4, then I would add 85 to both sides, and 12 plus 85 is going to put Taylor's score at a 97. Seems reasonable. 3 standard deviations above the mean. And it actually worked out to be a whole number. If the standard deviation is 4, 3 standard deviations above, 3 times 4 is 12. 85 plus 12 is 97. Makes sense. 2 more. Ross got a negative 2.5 as a standard as a z-score. I'm expecting Ross's score to be below 85. Ross's score minus 85 divided by 3. I'm sorry, the standard deviation was 4. Divided by 4. Going to my calculator. Actually, I'm not even using my calculator. I'm going to use my brain. To undo divide by 4, I multiply by 4. This is going to be negative 10 equals x minus 85. When I add 85 to both sides, negative 10 plus 85 is going to put me at a score of 75 for Ross. That makes sense. Ross was below the mean. He was well below the mean. 2.5 times 4 below the mean came out to be 75. And last but not least, Natalie, 1.25. What did Natalie score minus 85 divided by 4? Multiply 1.25 times 4, and I'm getting 5. 5 equals x minus 85. Let me add 85 to both sides and find out that Natalie scored a 90. I knew she would be above the mean because her z-score was positive. So in the case of example 4, I was working to do some undoing. I hope that you could follow this so you can finish up your assignment that's going to be due when I see you again. You've got the rest of class today. And anything you need to do overnight, I would make sure that any of these problems that have